Hi everyone, my name is Jingwen. I'm a PhD student of Nantes University. So I'm here present this work on behalf of my friend Vignesh and his colleague. So the title of this work is Transcoding Quality Prediction for Adaptive Video Streaming. I will first introduce their work and a short introduce of the M-stage transcoding model and the TQPM architecture, and then the evaluation and conclusion. So their work is based on the HTTP adaptive streaming. So first, why adaptive streaming? Because there are a wide range of different devices, and the speed of internet is very different. And what Hash does is, first, each source videos is split into a small segment, and each segment will be encoded at multiple bitrate resolutions and codec. And then which segment to deliver depends on the device capabilities, network speed, etc. Video transcoding has been considered as an efficient solution for in latency-sensitive video streaming applications. So this figures is an example scenario for video quality assessment in adaptive streaming applications. We can see that client A and B will receive the highest bitrate representation encoded by the oranging server. In contrast, client C, D, and E receives a lower bitrate presentations transcoded at H server. The quality video assessments in the state of art face three difficulties in video streaming applications. The first one is the original video segment is not available at the reference as reference at the destination. And the second one is the final reconstruction videos is not available at the source. And then last is the quality video assessment. The complexity is usually high, and it's not acceptable for online latency-sensitive service. And here is generalized M-stage transcoding model for Hash. The videos will be encoded in stage 1, for example, here E1 present for the encoded encoding. Stage 1 encoding, and D1 is stage 1 decoding, and B1 stands for the target bitrate. For E2 and D2, it's similar with E1 and D1. Oh, sorry. In this paper, they validated their work on m equals to 1 and m equals 2. So here, this formula presents the temporal complexity for the VQA at the source. So we can say that they need the time of encoding tau E1 and the time of decoding tau DI, and they are the sum of M stage. And then the time they need to apply the time for extracting features for the input video segment and the reconstructed video segment. We can see that it's very time-consuming, and it is not practical for live streaming, etc. So video quality assessment at the source by predicting the video quality using the input video segment characteristic, and also the transcoding system characteristic can solve this problem. So based on this, they proposed the TQPM architecture. There are three parts of their architecture. The first is the input video segment characterization which they extract features based on the input video segment. And the second part is they extract features from the transcoding model. And then, based on the two features, they applied a machine learning video quality prediction model. Okay, so the first part, the input video segment features, what they use is, there are three features. First one is E. It is a DCT-based energy function who will determine a block-wise features for each frames, and then each block will be averaged per frame. The higher E is, the higher temporal spatial complexity it is. There will be more texture, and then H is sum of average difference for the energy values, and it's just calculates the difference for the consecutive frames. So the higher H is, the high temporal complexity it is, and then L is the luminance of each blocks. It just takes the DC component of the DCT transformation, and they calculate the average of each block for per frame for the luminance features. And each video segment are divided into T chunks with a fixed number of frames, and the average of E, H, and L features will be used for each chunk. And the second part is the features from the transcoding models. There are two assumptions based on that for this paper. They assumed the settings of the encoding in the M-stage transcoding process are assumed to be identical, and the resolution corresponding to the target bitrates in the bitrate ladder are assumed to be fixed. So here is transcoding features characteristic. And then transcoding features will be appended to X, which is, I prefer to show it here. So they will be concatenated to the input video segment features, and then the 2D matrix will be fed into a machine learning model, LSTM, for the prediction to predict the video qualities. So then let's come to the evaluation. They evaluate their framework on this data set, and they encoded them with X265 and with a fixed frame rate. The preset is UTF-fast, and they use a fixed bitrate ladder here for the representations. And EHL features are extracted using VCA version 2.0. So here is the result. ABC is for single stage. DEF is for the stage 2 stage. We can see that the correlation, the predict quality is highly correlated with both for PSNR, SSM, and VMAF. And here the green dashed line stands for they use assumption of the GND threshold for VMAF is 6. So we can see that the most of the point drop in the GND threshold. And here is the prediction accuracy for PSNR, SSM, and VMAF for both M equals to 1 and 2. We can see that the prediction error for VMAF, for example, is around 3. And also one thing they would like to mention here is for the resolution here, 360p, it's already a very small bitrate, so they don't have the prediction for m equals 2. And also the average, the processing time for this model is like 4 seconds per segment. The complexity is very low. And then let's come to the conclusion. This paper proposed TPQM, an online transcoding quality prediction model for video streaming applications. And the proposed LSTM-based model use DCT energy-based features as reduced reference to characterize the input video segments, which is used to predict the visual quality of an M-stage transcoding process. And the proposed model is validated by the Apple HLS bitrate ladder encoding and transcoding using the H265 open source HEVC encoder. And the proposed method achieve a good performance both on PSNR, SSM, and VMAF, both for single stage and stage equals to 2. And future directions in the transcoding between bitrate ladder representations of various codecs shall be investigated. And another direction is defining decision-making components based on the proposed model in an end-to-end streaming system. And thank you for your attention. And this is a VCA open source resource and the email of the author.
Great, thank you. So we have